Hello, this is the Tepid Coder. In this video, I want to talk about different types of containers and why you might choose between different containers. So, in this, I want to talk about like maybe standard vector we've seen. I'm going to use it for something we shouldn't be using it for, and then I'm going to use something else in place of it rather. I'm also going to show a set. I'm going to show unordered map, and I'm going to show map. Okay, so first of all, what am I going to do here? Imagine we have some options. Let's have some data type we can hold that's really easy to work with, like a string, right? So we have a vector of strings. We'll call it vec options, okay? I'm going to use an initializer list to add a bunch of elements. I'm going to say cat. How about dog's an option? Then we have, I don't know, lemons is an option. Then we have, I don't know, how about mud? Let's imagine people are like joining us and like using, I don't know, ballots or suggestions, and every time someone suggests something, they just throw it in the lot, right? Throw it in the bin, and like we're eventually going to sort through these and figure out what options we have. Someone else also says cat, and we have another dog lover, and I don't know, maybe we get two muds in a row when we're looking through this bin of options. Whatever the case may be, right? So we have some duplicates in here. Now, if I do this, let's say we iterate through these and show them all first. I'm going to say auto, I'll do const auto, stir option, which comes from vec options. First of all, let's just look at them. So standard cout, we're going to do stir option. Okay. Line. Okay, we're going to do something like option, I'll put it in quotes. Okay. Let's just show that working real quick. So g++ test tp out test, and I didn't include iostream, so that's going to be an issue. Iostream. Okay. And I can see the options here: cat, dog, lemons, mud, bud, cat, dog. Now, what if we just want to know which unique options exist? We don't want any duplicates. We just want to see what kind of options people came up with, and we just want a list of that. So what we can do is there's a standard algorithm called unique. We can call that on many different container types. And the kind of container type you can call it on depends on, I think, whether it has a, is it random access iterator? Let me take a look at this real quick. Type requirements. It needs a legacy forward iterator, and it must meet the requirements of move assignable. So essentially, a forward iterator just means you can go from one element to the next. That's basically every container. Like even a list you can do that, even though it doesn't have random access. Like a standard deck, if I have a deck of characters, let's call it DEQ, right? I can do something like DEQ 5, right, and get a 6th element. I can do that. Now with a list, standard list of characters, I couldn't do that. Standard list char, st. I couldn't say list 5. But I could say, you know, I have some list iterator, like standard list char iterator equals list dot begin. Then I could do something like, give it a name, it. I could say it++, right? That's a forward iterator. It goes to the next element of the list, next iterator. So this unique thing requires that it's at least a forward iterator. So I'm going to say we're going to get unique options from vec options begin up to the end of the range, which is going to be vec options.end. Okay. And this is going to return an iterator, standard vector string is our type, iterator, it. What I can do is I can sort the vector, vec options begin. Okay, I'm going to do vec options end. So I'm sorting the entire vector, and then I'm getting a iterator that points to the first of the duplicates. And I'm going to say vec options.erase, I'll get rid of all the duplicates. I'm going to say from that iterator, it, up to vec options.end, up to the end of the vector. Okay, now we're going to print out all the options. There shouldn't be any duplicates anymore. Let's see if that works. And there we go, cat, dog, lemons, mud. So that works, but that's a lot of work, right? I don't really want to go through that much work every time I have a unique set of something. So another thing I could do is instead of using a vector like this, I could be sticking stuff into what's called a set. So well, I could just use initialize list for the set. I'm not going to. I'm just going to iterate through the vector and create a set and just show how it works. So I'm going to say standard set of type string, standard string. Okay, I'm going to call it set options. Now, every time I iterate through one of these options, and right now, I'll show the options as well, right? I'll say adding option whatever to the set. Okay. The set's only ever going to have one of each type of item. That's what a set's for. So set options, insert, and we're going to insert stir option. Now I can do for const auto stir option again, but this time it's going to come from set options. Okay, I'm going to say, just paste that in here. I'm trying to be quick about this. So option. Okay, so we're going to show the options in the set. And there we go. So we added all of these options to it, you see, but it still only has cat, dog, lemons, mud. So that's pretty cool. So if we want a unique list of something, it's way easier just to use a set. Especially if we know in advance, we'll just put things in the set from the very get-go. Now something else we can do, say we want to know how many times each thing appeared in the set, right? Or inside this vector, right? Maybe these are votes. People are voting for cats, dogs, lemons, and mud. Okay. In this case, what you can do is you can actually use something like a map of a key to a value. And every time you see that key, you just add 1 to it. So what I'm going to say is I have a standard unordered map, let's say. I don't care what order they appear in when I iterate through them. I'm going to say it's a map of the option, a string, to the count of that, number of times it appeared, which is going to be a size t. So for unordered map, I'll say options. Now see the same thing we did before, const auto stir option from this vec options. And for each one, we're just going to say if options.find, we're going to find stir option equals options.in. So if we couldn't find it, then we're going to add it options stir option. So that's our key. Equals, so it's going to create it if it doesn't equal and return the reference to that option, which is a string. Return that string reference at that key. It's going to equal 1. It's the first time we've seen it. Okay, otherwise, we're going to say options stir option plus plus. So if we see it again, we're going to add to it. Now, when we're done with that, we're going to say for const auto stir option. Actually, I'm going to do that. I'm going to say structured binding, comma, st count, right? So I'll say instance count, how many times it was there, how many times we saw the option. So that comes from options, that's what we're iterating through, okay. Okay, we're going to say standard cout, option, whatever, had some number of votes, okay. st instance count. Let's do that. 1. And I'll show the option. Stir option. Okay, let's try that. Okay, we can see lemons appeared once, mud appeared twice, cat appeared twice, and dog appeared twice. Lemons, mud, dog, cat. Okay, if I actually look at this, is that right? We have 1 cat, 2 cat, 1 dog, 2 dog. 1 lemon, that's it, 2 muds. Okay, so that works. Now, something to keep in mind here is this is unordered, so when you iterate through this, it's not guaranteed it's going to be in this order, lemon, mud, dog, cat. It might change, it might not. It's there's no guarantee at all what the ordering is going to be. But if you want to guarantee the ordering and have it be alphabetical order, or rather ascending order, I should say, we can basically do the same thing, but instead of an unordered map, we just use a regular map. So let's do that. And every time I see unordered, let's replace that with nothing. Yes. Oops. No. Still have the underscore there. Okay. I think that's probably good, maybe. Might have forgotten some, we'll see. Okay, that worked. And you can see it's alphabetized now. Cat, dog, lemons, mud. That'll always be true for a regular standard map. Anyway, I hope this was helpful. If you have something like a vector where you don't care about duplicates, that's great. A vector is a great way to store just an assortment of elements when you don't really care about duplicates or how many of each you have. if you want to know that each thing has some associated value, you're going to want to use a map or unordered map. Typically, unordered map is better, but if you actually want to show like a list of options like in a drop-down menu or something, you probably want it alphabetized. In that case, you would just use a standard map, which does that for you. Now, if you want to have only a unique list of something, while a map and unordered map would do that for you, because each key is just going to replace its value when you use it, a set is also intended for that. So if it's not associated with anything, a set is the best option. And if for some reason you're storing things in a vector because you need to use a vector for some reason, or it's just, it's required for whatever reason, you can always convert that into a list of unique items using this by sorting and then using standard unique to get the things pushed to the end of the list, all the duplicates, and then you get the iterator to the first duplicate, essentially, because you sorted it, and you erase everything from there to the end. So anyway, if anyone has any comments or suggestions, please post those. If you liked the video, please give it a thumbs up, and subscribe if you feel like seeing more of this content. And I suppose I will catch you guys later. Have a good one.